Section 1.3, Rates of Change and Behaviors of Graphs. In this section, we'll first find the average rate of change for a function over a certain interval, and then describe the behavior of functions, increase, decrease, maximum, minimum, both relative and absolute. The average rate of change of a function is the change in the y variable divided by the change in the x variable. And you may recognize this as a concept that you're familiar with already. It's just the concept of slope. For notation, so that we don't have to keep writing change in y over change in x, there's an abbreviation for change, and it's this little triangle here. And that triangle is called a delta. So we can write this as delta y, change in y, over delta x, change in x. It's just a way of shortening the notation. In the formula, to find the change in y, you simply subtract the y coordinates, and to find the change in x, you simply subtract the x coordinates. And this is how you find the average rate of change of a function over an interval, or in other words, the slope. So here are some examples of rates of change. For example, one might say, if you're interested in economics, the economy grew at a rate of 3% per quarter. So in other words, the change was for every 1 quarter, the economy grew 3%. My car gets 50 miles per gallon. For every 1 gallon of gas, my car drives about 50 miles. The speed limit on most freeways is 65 miles per hour. So in 1 hour, the car should go about 65 miles. So here's an example of finding average rate of change in context. Beanstalks grow very quickly. When I planted my beanstalk, it was 6 inches tall, and 1 week or 7 days later, it was 20 inches tall. What was my beanstalk's average rate of change? So if you wanted to, we could actually even draw a picture of this. So initially, you have a beanstalk, and then the beanstalk grew. Now the time it took for the beanstalk to grow was 7 days. And initially, the beanstalk was 6 inches tall. And in the end, 1 week later, it was 20 inches tall. And so we wanted to find the average rate of change. It's the change in the y variable, the change in the height, divided by the change in x, and the x variable is days. So if we thought about this as ordered pairs, on day 0, when I initially planted my beanstalk, it was 6 inches tall, and 7 days later, it was 20 inches tall. So to find the change in height, 20 minus 6 over how much time had passed was 7 minus 0. And this gives us a total of 14 over 7, or in other words, 2. Now sometimes when you want to interpret the average rate of change, it's nice to keep it written as a fraction. And so the change in height was 2, and the change in days is 1. So what that means is for each day, for every 1 day, it grew about 2 inches. Or in other words, the rate of change was 2 inches per day. So that's an example of rate of change in context. Let's take a look at some examples in algebra. Find the average rate of change of a function. Find the average rate of change of this function, f of t equals t squared plus 2t minus 1, over the interval from 1 to 5. So the first thing we're going to do is we're going to change this into some points that we can work with. So here's the basic idea. Here we have x is equal to 1, and here we have x is equal to 5, and we have some kind of function. And so what we'd like to do is we'd like to find the slope between the 2 points where t is 1 and where t is 5. So the first thing we're going to do is we're going to find out what f of 1 is equal to. So to find out what f of 1 is equal to, we have 1 squared plus 2 times 1 minus 1, or in other words, 1 plus 2 minus 1, which gives us a value of 2. So we know that this point here is 1, 2. Next, we'll find out what f of 5 is. So f of 5 is 5 squared plus 2 times 5 minus 1. That's 25 plus 10 minus 1, and that's equal to 34. So our second point is the point 5, 34. Now to find the average rate of change, which again is just a familiar concept to you, the slope, we're going to find the change in y divided by the change in x. So the only thing we have to be careful of is what are our coordinates, what are our y coordinates, and which are our x coordinates. So here we have our y coordinates, so that's going to be 34 minus 2 divided by, and now let's take a look at our x coordinates. Our x coordinates are 1 and 5, so we have 5 minus 1. And so when we compute this, we're going to have 32, 4 minus 2 is 32, divided by 5 minus 1 is 4. And you can just leave your answer like that, or if you want, you could reduce it. So if we were to reduce this, we could write this as 8 over 1. Or you could just write 8. So for every additional x unit of 1, y tends to increase by about 8 units. Find the average rate of change of f of x over the interval from 1 to a. Now notice in this problem, our second coordinate has a variable in it. So we're going to expect that our answer also has a variable in it. All right, so just like before, we're going to find our points. We already know that f of 1 is 2. So our first point is 1, 2. Now let's find out what f of a is. F of a would be equal to a squared plus 2a minus 1. And so our second coordinate, when we put in a, our y coordinate would be a squared plus 2a minus 1. And now we're going to do the same thing that we did before, change in y over change in x. So let's take a look at our y coordinates. Our y coordinates are 2 and a squared plus 2a minus 1. So that gives us a squared plus 2a minus 1 minus 2. And now let's look at our x coordinates. Our x coordinates are 1 and a. And so this will be divided by a minus 1. And if we simplify this, let's see what we get. Here we have a squared plus 2a minus 3 over a minus 1. Now, there is a last minute touch that we need to do here. We have to ask ourselves, can we simplify this? Now, when we see an expression like this, the way we know we can simplify it is by asking ourselves, can we factor? So simplify means, can we factor and cancel? If we can, then we will go ahead and do so. And if we can't, then we're done. So if we take a look at this numerator and see if we can factor it, that's going to factor as a plus 3 times a minus 1. And in the denominator, we had an a minus 1. And so what we can notice is that we have two common factors, which we can cancel because they're equal to 1. And so our final answer is going to be a plus 3. You might ask, is it necessary to simplify? And the answer is yes. If we can simplify, we need to go ahead and do so. You can also find average rate of change from a table. So here we have a table of values showing time and distance. After picking up a friend who lives 20 miles away, a student records her distance from home over time. and her distance is shown in the table. What was her average speed over the whole trip? So for the whole trip, we want to start with the initial time, which was 0, and the ending time, which was 7 hours later. And so we have the points 0, 10, and 7, 300. And again, average rate of change is just slope, change in y over change in x. So that would be 300 minus 10 divided by 7 minus 0. So this would give us 290 divided by 7. And we can either leave it like that or we can reduce it. So let's find a calculator. And if we divide 290 divided by 7, we get about 41.42. So this is about 41.4 over 1. And again, what was this? This is miles, and this is hours. So her average rate of speed was a little over 41 miles per hour. So about 41.4 miles per hour. Compare her average rate of speed for the first half and the second half of the trips. So now, instead of looking at the whole trip, we're only looking at two parts, the first half and the second half. So if we look at our table, the first half and the second half would be hours 0 through 3 would be the first half, and then hours 4 to 7 would be the second half. So for the first half of the trip, we have the points 0, 10 and 3, 153. So again, if we find the slope, the average rate of change, that's going to be 153 minus 10 divided by 3 minus 0. And if we work that out, that's 143 divided by 3. And again, if we take a calculator and compute that, we get about 47.7 miles per gallon, or excuse me, miles per hour. And if we look at the second half, so again, the second half would be 4, 214, and then we would have 7, 300. We're going to do exactly the same thing. So change in y over change in x. We would have 300 minus 214 divided by 7 minus 4. And if we take a look at that, 300 minus 214 is 86. So this would be 86 divided by 3. And 86 divided by 3 is about equal to 28.7 miles per hour. So you can see that in the first half of the trip, she was able to travel much more quickly than in the second half of the trip. So that's a lot for right now. So why don't you give a few problems a try, and then we'll come back and we'll finish this section.